Hello, and welcome to this lesson on a limited topic within the GMAT quantitative section, descriptive statistics. So let's begin by just considering the simplest of all descriptive statistics, an average or arithmetic mean. You'll see the terms used interchangeably on this exam. So the average can always be calculated just by taking the sum of the values you have within a set or sequence and dividing by the number of terms within the same set or sequence as defined. A weighted average means that you have an inconsistent variance in terms, and you'll have to manually calculate that every time. Using a device that we'll talk about here in a moment called the average circle will make that really easy. And that means that your set is something like, say, 4, 7, 82, 98, 737. There's no distinct constant value, either from a multiplication, a proportional standpoint, or just a constant addition that would allow you to call it an unweighted average. So an unweighted average means that you have a constant difference between each and every term in your sequence, and that has some implications that the GMAT really likes to exploit. And if you know some of the ins and outs here, you're going to have potentially faster paths to solving questions involving averages and, by extension, medians. So for instance, 5, 10, 15, 20, 25 would be an unweighted sequence that would have an unweighted average because you've got a constant difference of 5 between 5, 10, 10 and 15, 15 and 20, and 20 and 25. And that means that no matter which two terms you take, as long as the terms are equidistant from each other, you'll have the average of the set. So, for instance, 5 plus 25 divided by 2, that's 15. 30 divided by 2 is 15. Same with 10 and 20. 10 plus 20 divided by 2, 30 divided by 2, 15 again. So if you've got two terms that are equidistant from each other, equidistant from the median, you can actually solve for the average just from those two terms. And the median is going to be your central term when your arithmetic values are placed in numeric order. And it's the single central term if the number of terms is odd. So when you're considering median on this exam, you really want to first note whether you're dealing with an odd number of terms or an even number of terms. Because if it's an odd number of terms, you just got to set the numbers in order and then pick the one that is directly in the middle. But if you have an even number of terms, you have to take the average of the two central terms because the average or the number of terms is even. Because there is no single middle value. You actually have to take the two in the middle, sum them, divide by 2, and you'll have your median. And as we just talked about, your average is equal to the median if you have an unweighted set or sequence like 5, 10, 15, 20, or 25. So we see that the median of that set is equal to the average. It's 15 for both. So again, lots of implications here because it might be easier to find the median and then find the sum. There's a whole bunch of different things that you can find just from knowing you've got an unweighted sequence. So let's consider that device I talked about that will help you evaluate averages. It's going to be the average circle. So this is just a visual representation of the three pieces that go into an average. So you can see on top, we've got the sum of the terms. On the bottom left of the circle, we've got the number of terms. And on the bottom right of the circle, we've got the average. And if you take any of these two values using the operands you see on the circle, you'll be able to solve for the third. So to use the circle, you just have that visual representation. And as I said, any two values can solve for the third. So you can use multiple circles to coordinate complex averages. So if you've got multiple things happening, you can sometimes organize them with this circle to solve for whatever it is the question is specifically asking for. And that means you can add or subtract raw numbers, meaning the sum of the terms or the number of terms, but you can't add averages across multiple circles. So for instance, if I'm asking for the average number of students at a school dance over 12 months, I can't just add the averages and then divide. I've got to find out the actual numbers of totals in those months, but I can add those numbers and then divide by a different number of months and potentially find averages for subsequent or remaining numbers of months. So you can add or subtract your number of terms, your sum of the terms. Just beware of adding and subtracting the averages directly because that's where the weighting comes in. If you do try to add the averages, you'll not appropriately account for weights usually. So going back just into our statistics, we start back in with range. Range just means your greatest term minus the least term. about as simple as it comes, except for mode, which is even easier. You're just looking at your most frequently occurring term or terms. You can't have multiple modes. Again, something the exam is exceedingly unlikely to test, but theoretically you could. Standard deviation is the statistic that most students concern themselves most with as they begin their studies for the GMAT. Now, here's the good news. It should never be fully calculated on this exam. You are not going to need to square the differences and all of those steps. It's just too time consuming. Instead, what you will require for excelling on this exam for the one or two tops standard deviation questions you'll encounter on the GMAT is just a broad conceptual understanding of what deviation requires from a calculation standpoint. And that's going to be your average. You need to know the average, and you will technically need to know the distance between each and every term in order to solve for your standard deviation. Again, you won't actually want to do that, but you need to know some proportional pieces. For instance, you need to know that if your differences in your terms increase, then your deviation is going to increase. So that means that the set 1, 2, 3, 4, 5 has a smaller deviation than, say, 1, 5, 9, 38, 52. Because there's bigger differences between the second set, you're going to have a larger deviation. Similarly, you're going to have an instance where if the differences decrease in your set or sequence, your deviation is going to decrease. Again, it's just based on proportionality. If, however, you have no difference in your terms, say your set is 5, 5, 5, 5, 5, 5, and 5, then your deviation is 0 because there is no difference between any of those terms. Again, the sorts of things that the exam might expect you to recognize. And if you were to have no change in your differences, you're going to have no change in standard deviation. So whatever the deviation is, and we don't really care, of 5, 10, 15, 20, 25, that's the exact same deviation as 105, 110, 115, 120, and 125 as a set. Because all you've done is add 100 to each of the terms, those differences remain the same, so your standard deviation itself would have no change either. So, now we've got to talk about the only thing that you really need to memorize when it comes to descriptive statistics on this exam, and that's the normal distribution curve, which you can see outlined here. Now, I will admit that the things above 2 and 3 are probably a little bit excessive. You could summarize in most ways that basically above and below 2 deviations from the mean is going to be 2.5% rather than breaking it into the 3, but it's never a bad idea to have a little bit more information than the average exam question will require. Now, to evaluate your distribution, you're going to have a constant percentage distribution for the deviation. So you can see there's a 68% distribution between the average and one deviation of the mean on either side of the mean. So you can see 34 plus 34 is 68. Then you're going to have 27% between 1 and 2 deviations of the mean, positive and negative. So that's your 13.5 times 2, 27%. And then you're going to have 5% that is more than 2 deviations from the mean on the positive and negative side. So that's your 2.5% above 2 standard deviations and your 2.5% below 2 standard deviations. Now, the other thing to note is that you've got exactly 50% of your distribution above the mean and exactly 50% below the mean. Again, they expect you to know these things broadly, conceptually. They don't require you to fully calculate. So by just knowing the normal distribution curve and its percentage distributions, as well as the basic proportionality of standard deviation, you should be more than on your way to success for statistical evaluation of problem solving and data sufficiency problems on the GMAT quantitative section. So now that we've got that basic understanding of descriptive statistics as required by the test, let's go move over to the whiteboard and take a look at a few example problems illustrating these concepts in our GMAT quantitative formats. Okay, so let's apply some of that knowledge we just got about GMAT descriptive statistics to an example problem or 3 here on the whiteboard. So let's go ahead and set up the scratch pad as we always should to begin by skipping to the end of the problem and setting up our answer choices. So our answer choices are real numbers here. So we're just going to have those listed out: 65, 73, 82, 92, and 111.5. So we skip to the end. We're being asked for the lowest possible on the final 2, on one of the final 2. for a 90 average. And it's a relatively lengthy little setup, but we know we want to just immediately figure out what we're being asked for so that we're not wasting time rereading this problem. So far this quarter, we know that Pearl has taken 3 of 5 course exams, scoring 90, 92, and 95 on a 100-point scale for each. So that means that we've got a total points possible of 300. And her total score for the first 3 is going to be equal to 90 plus 92, which is 182, plus 95, which is going to be 182 plus 100 minus 5, so 282, 277 so far. And this is our opportunity to introduce those average circles, because we know from the setup here that her sum total is 277 right now for her total score. And we know that her average overall we're seeking is 90 on 5 tests. So that means her score goal is going to be a 450 in total. So that is for all 5. Now, the remaining 2, so we know that 450 minus 277, which if we did 450 minus 300, that would be a 150. 150 plus 23 back is going to be 173 is needed on the final 2. And we know that the maximum possible is 100 for either. So that means that the minimum possible is going to be equal to 173 minus that maximum of 100 is equal to 73. And there's our answer for choice B. So you can see how just organizing using the little average circle, knowing that our number of terms of 5 times the 90 average that was sought can easily allow us to figure out what the total is for all 5 exams in terms of raw points. And then we just have to subtract out what she's gotten so far, figure out what she has that's left, and then logically figure out what the minimum for either would be by maximizing the other of the 2 exams. So now let's just scroll down and we'll take a look at another descriptive statistics concept of standard deviation. So once again, we're going to set up the scratch pad same way as always. So we've got A, B, C, D, E here. Answer choices are real numbers, so 10, 20, 40, 80, and 200. And we skip to the end, we're being asked for the number of students, not students, students score over a 95. So immediately start taking notes at the beginning. So we've got a total that is equal to 400. And we find that the average score is equal to 85. And then they introduce the concept that is key to this problem. The standard deviation of the class midterm scores is 5. So we have to draw that normal distribution curve. So bear with me as I try to draw straight here. Third time's going to be a charm. I can feel it. We'll do one more. Nope. There it goes. Look at that straight line this time around. And then we're just going to have kind of a hump in the middle, and this is going to be my average. And so then we just have to draw out the curve from memory because we are going to need it from what we saw moments ago. So you've got -1 standard deviation here, +1 standard deviation here, -2 standard deviations over here, and +2 standard deviations to the right. And we remember that we've got an average of 85 and a deviation of 5. So that means that we're basically adding that constant of 5 or subtracting that constant of 5 from each deviation. And we're only going to 2 deviations because we will only need those. So 85 plus 5 means 90 is 1 standard deviation above the mean. We know that 95 is 2 standard deviations above the mean. And then 80 and 75 go this way. And we recall the distribution curve. For ease of use, we know that we basically have 34% between the mean and one standard deviation on either side because you've got an equal distribution. Then we're going to have 13.5 here and 13.5 here. So that means we've got 68 plus 27% accounted for, because 13.5 times 2 is 27. And that, of course, gets us up to our 95%. So that leaves us the 2.5% on either side of two standard deviations away from the mean. So that means that the students who scored above a 95 are going to be 2.5% of 400. Now, you may be thinking to yourself, well, how am I supposed to take 2.5% of 400? Well, the easiest way is to just take 10% of 400 to start. So 10% is going to be equal to 40, which means that 5% is just divide by 2 is going to be 20, and just divide by 2 again to discover that 2.5% is going to be 10 students. And there is our answer for this one. So remember that standard deviation curve, normal distribution, because you will need it potentially for a problem like this if you don't have that bit of information memorized. And really, it's the high end of statistics that's going to be required. That's all you need, and you can make this a relatively simple evaluation. So then let's take a look at one more problem, a data sufficiency, considering how the exam can test these descriptive statistics using these problem formats. So we start out with what we know, and we know that we've got an average and we've got set S. So set S is what we know, and we're going to have the terms, or the number of terms, of set S. We'll just call that T. And we know that the sum of the terms of set S, we're going to just call that X. And right now, I don't really know anything, because what I'm being asked to solve for is the average of set S. So we'll just box that off, as we always do. And we know that what we need in this case is going to be a way to solve for the sum of the terms X divided by the number of terms T. And remember, try to convert all of this information into algebra so that you can evaluate it without necessarily plugging in a bunch of different outcomes and seeing different ways to work through it, because that's going to take a lot more time than we'd like to for this relatively straightforward and simple problem, at least as it appears to start. So condition 1, well, this tells me that the number of terms, T, is equal to 30. Wonderful. By itself, that is not sufficient, because I have no idea what X is, the sum of the terms. So that is eliminated, and we're down to B, C, or E. Then condition 2 tells us that the median of set S is equal to 40. Well, by itself, that doesn't tell me anything. It isn't even the average. So that's out. And we can, of course, eliminate choice B. Then when we combine the two, well, I still don't know the sum of the terms. So I can't solve, and I don't know that the median is equal to the average. So don't assume that the median here is equal to the average, because we don't know. It might be a consecutive sequence, an unweighted sequence with a constant difference between all of the terms, or it might not. So that's one of the big things you have to be aware of, is unwarranted assumptions, both here and ultimately on the critical reasoning in the verbal section. So here, we don't get what we need. We X that out, cross out C, and we select choice E. So use these tools regarding the basics of descriptive statistics that the GMAT's going to test as you practice more statistics-based problems for the GMAT quantitative section, both problem solving and data sufficiency.